Okay, let's take a look at this problem. First thing, we cannot have any number in front of our x. So, as my first step, I'm going to factor out a -2. Now you have to remember that to factor means to divide out. So this would be a minus pi divided by -2. Which is going to give us -2 there, and a negative becomes positive. So we got x plus pi over 2, and then plus 1. Now that negative you see right there, we can take that and we can put it out in front because it's an odd function. So that gives us -1/3 tangent 2 times x plus pi over 2 plus 1. Now first thing we'll notice is this plus 1 means that our graphs can be shifted up one unit. This plus pi over 2 means it's going to be shifted left pi over 2, which means I can look at the simpler function, y is equal to -1/3 tangent, and we'll ignore this part and we'll ignore this part, so we're just looking at tangent 2x. So much simpler to look at that and then just take that graph and shift it left and up. Now our b is going to equal to 2, and our period for tangent is pi over b. We just said b is 2, so we'll have pi over 2. Now we want to build a t-chart for this. -1/3 tangent 2x. Now our first entry here is always 0. Our last entry is always our period. So that's p. Here in the middle it'll be half of p, which is 1/2 times pi over 2, which is pi over 4. This will be 1/4 times p. 1/4 times pi over 2 is pi over 8. And this one will be 3/4 of our period. And 3/4 times pi over 2 is 3 pi over 8. Now if I plug each one of those in, I'm going to have y is equal to -1/3 tangent of 2 times 0, which is -1/3 tangent of 0. Here we'll have y is equal to -1/3 tangent of 2 times pi over 8, which is -1/3 tangent pi over 4. And this is y is equal to -1/3 tangent 2 times pi over 4. So I'm just plugging in my x values. This is going to give us -1/3 tangent of pi over 2. And here we got y is equal to -1/3 tangent of 2 times 3 pi over 8, which is -1/3 tangent of 3 pi over 4. And we got y is equal to -1/3 tangent 2 times pi over 2, which is -1/3 tangent of pi. Okay, so we're going around our unit circle here. Remember, tangent is y over x. So I look at tangent as 0. Well, here's 0, y over x. 0 over 1 would be 0. 0 times negative 1/3 is 0. Tangent of pi over 4. Y over x, square root of 2 over 2 over square root of 2 over 2 is 1. So this would give us negative 1/3 times 1, or negative 1/3. Now pi over 2. Here's pi over 2, y over x. I'd have 1 over 0, which is undefined. So that's undefined. 3 pi over 4. Y over x, square root of 2 over 2 over negative square root of 2 over 2 is negative 1. Negative 1/3 times negative 1 is a positive 1/3. And then at pi, y over x, 0 over negative 1 is 0. 0 times negative 1/3 is 0. So that'd be our t-chart. Okay, so we got 0, 0. And it looks like our largest value is pi over 2. And let me think. Pi over 2 is approximately, pi is approximately 3. 3 divided by 2 is 1.5. So that's approximately 1.5. Okay, so here will be pi over 4. And here will be pi over 8. And this one is 3 pi over 8. Now if this distance here is approximately 1.5, then we want 1/3 and negative 1/3, which is 0.3. So if that's 1.5, 1.5 would be about right up here. 0.3, let's say, is right here. It's probably as good as I'm going to guesstimate it. 0.7 would be about right here. 0.3 would actually be a little bit lower, wouldn't it? Let's say right there. And negative 0.3 would be right here. If you're trying to get a fairly accurate graph, it's nice to keep it consistent. If this distance is 1.5 here, then that distance should also be 1.5. Okay, so then 0, 0, pi over 8 and negative 1/3, which would be, actually, I'm put them in red. Okay. Be right there. Pi over 4 is undefined, which means there's an asymptote there. And then 3 pi over 8 and 1/3. Be about right there. Pi over 2 and 0 would be about right there. Now I could use that to kind of guesstimate where the next one will be, seeing the pattern. So then this will be right about right here. And then our next one, about that same distance over, will be another asymptote. Which means that our graph, coming along here, remember it's got a curve to it, so it comes here, curves. More or less looks like that. And then I could have 2 cycles of that, but it just says graph 1 cycle. Now this is not our answer. At this point, remember we have to move it left pi over 2 and up 1. Left pi over 2 and up 1. And up 1. Probably going to do a poor job of estimating this, but you'll get the idea, I think. If that's 1.5, split in thirds, about right there. Let's say this is 1. Okay. And left pi over 2, this distance is pi over 2. So if I move this up 1, and 1's a distance that corresponds to this, so move it up that much, that would be about right here, this point. This point right here would be about right there. And this point here would be about right there. And then I'd move those left 1.5. And again, the distance of 1.5 is about that distance right there. And this one, move about that distance. And this one about that distance. So as close as I'm going to get it, that would be our graph there. Okay. Let me clear that off. Now we'll take a look at 10.6. So 10.6 is on page 853. Okay, and we're going to look at number 3. This says arc sine of negative square root of 2 over 2. Now, if we were to set this equal to a variable like p, that says p is equal to arc sine of negative square root of 2 over 2. I ought to read the directions, I guess. Find the exact value. If I then take sine of both sides, sine and arc sine cancel each other. So we got sine is equal to negative square root of 2 over 2. Now sine in terms of our unit circle is the y values. There's two places where it's equal to negative square root of 2 over 2. And again, we're looking at our y values. Here's negative square root of 2 over 2, and here's negative square root of 2 over 2. So we got 5 pi over 4 and 7 pi over 4. Let me undo those. There we go. But there's a problem with that. We have to look where arc sine is valid. And arc sine is valid only from negative pi over 2 to pi over 2. Which means that, first off, this 5 pi over 4 is not in there. So I can't use that. But 7 pi over 4, well, technically that's in that. But when we're looking from negative pi over 2 to pi over 2, 7 pi over 4 isn't between those two values. Which means that we need to do something to adjust it so it is equal to those values. And what we can do is we can take 7 pi over 4 and subtract 2 pi. Because remember, if you subtract or add 2 pi, you go all the way around the unit circle back to where you started. And that gives us negative pi over 4. Which is in between negative pi over 2 and a pi over 2. So that would be our answer. Number 64. Okay. I'm not sure where my page went to there. Let me try that again. 853. There we go. $64. We got cosine of arc cosine of 5/13. Okay. Find the exact value state that's undefined. Assuming that whatever value you have in here is valid for this outer function, which it is, cosine bounces back and forth between -1 and 1, so 5/13 is valid. Then assuming that's true, these two will cancel each other away. So that gives us 5/13. And that's our answer. Number 91. We got arcsine of sine of 4 pi over 3. Got a problem with this. If I look at this value here and I see if it's valid for arcsine, well, arcsine is from -pi over 2, to pi over 2. 4 pi over 3 doesn't fall in there. Well, let's kind of sketch this, see what in the world we're dealing with. 4 pi over 3. That's 1 and 1/3 pi's. So if clear over here is pi, then approximately 4 pi over 3 will be right over here. Now, if I were to go on my unit circle at this point we're looking at, straight over to this side, to that point on our unit circle, well, the y values are the same. Why are we looking at the y values? Because we're looking at sine. And remember, sine on a unit circle is the y values. So the y values are the same here. Well, over to here was pi, and this was another pi over 3. Which means this value right here is -pi over 3. So we can replace the 4 pi over 3 with -pi over 3. And why do I do that? Well, -pi over 3 is between -pi over 2 and pi over 2, and that's what our goal is. And now this value here is valid for arcsine. And if it is valid for this outer function, then arcsine and sine are going to cancel each other, and our answer is -pi over 3. Let me clear up that page. What problem was that? That was 91. Okay, 190. Okay, 190. We got sine x is equal to -0.569. It says solve the equation using techniques, then approximate solutions lie in the intervals 0 to 2 pi. So it looks like we're 0 to 2 pi implies radians, 4 decimal places. Okay, I'm not going to approximate it. I'm just going to use my calculator. So we can take inverse sine of both sides. That's the same as arcsine. Sine x is equal to inverse sine of -0.569. Now inverse sine and sine cancel each other. And then on our calculator, we need to make sure we're in radians. So I'm doing this on T83, T84. I'm doing mode, and then I'm choosing radians. You'd have to look at your documentation, see how to change the radians in whatever calculator you have. I pressed enter on radians and select it. Then I'm doing the second mode exit out. Okay, so for our inverse sine, that's above our sine. So we'll do second and then sine and then -0.569. And in 4 decimal places, we'll have -0.6053. And that would be our answer. Okay, number 209. 5, 12, and 13. And it says, find the two acute angles in the right triangle sides of the given lengths. Express your answers using degree measures rounded to decimal places. Okay. So if I were to draw that, your longest side has to be your hypotenuse. So that's 13. And I'll say this is side, this will be C for hypotenuse. And A, I'll say is 12, or you could say it's 5. It doesn't matter which one you assign to which. And I'll say B is equal to 5. Okay. Now, this angle right here is going to be angle A. The side that's opposite side C is angle A. The side that's opposite side B is angle B. Now, if I pick one of the angles to work with, let's say I work with A. And I'm going to say tangent of A is equal to opposite over adjacent. Well, if I look at it in terms of A, the side opposite of it is this side here, is 12. And the side that's adjacent to it is this 5. Now, if I take inverse tangent of both sides, this is going to give me what my angle is. Inverse tangent and tangent cancel each other away. Now, it said that we have to be in degrees, so back in my calculator, I'm going to go to mode, and I'll choose degrees, exit out, and then I'm going to do second tangent for inverse tangent of 12/5. And that's 67.38. Now, if it's a right triangle, well, actually a triangle, we know it's 180 degrees, but right triangle tells us this is 90, and so these two have to add up to 90. So to find B, I simply have to subtract A from 90. So I do 90 minus 67.38. And I'm not very good at basic math. Let me check it. 90 minus 67.38. 22.62. And those would be our two angles. Okay, that's it for 10.6. Let me go to 10.7. Number 12. This is on page 883. Number 12. Ooh, these are very, very nice. Let me clear that off just so I have enough space. I shouldn't say sometimes they're okay, sometimes they're not very nice. Number 12, we got 2 cosine of x plus 7 pi over 4 is equal to square root of 3. Well, first thing we have to do is we have to get cosine by itself. Can't have a number in front of it. So we divide both sides by 2. So I get cosine of x plus 7 pi over 4 is equal to the square root of 3 over 2. Okay. Cosine in terms of our unit circle is the x part of our point. So keep that in mind. Now we're specifically looking where cosine is equal to square root of 3 over 2. Well, square root of 3 over 2, one of them is right there, and the other one is right down here. Okay. So we got the fact that cosine of pi over 6 is equal to square root of 3 over 2. We also got that cosine of 11 pi over 6 is also equal to square root of 3 over 2. Now our instructions say to find all of the exact solutions and then list those solutions which are in interval 0 to 2 pi. Okay. All the solutions means I need to keep going, which means if I take pi over 6 and I add 2 pi onto it, it will also be equal to square root of 3 over 2. Because remember, if you add or subtract 2 pi, going all the way around unit circle, back to where you started. In this one, if I do cosine of 11 pi over 6 and I add 2 pi, I'm back to where I started. So that's also equal to square root of 3 over 2. Now I could go the rest of my life listing all the possibilities, but that's going to be enough there, I believe. We'll see. Okay. Now what we do is we take each one of these values here that we found, and we're going to set it equal to what's inside the parentheses up here. So, for example, I'm going to take x plus 7 pi over 4 is equal to pi over 6. Now if I get rid of the fractions, I multiply everything by 12. So I'd get 12x plus 21 pi is equal to 2 pi. Let me double check that. Times 12. 12x, 21, 2 pi. Okay, so then we take the 21 pi over. I get 2 pi minus 21 pi. So I got 12x is equal to negative 19 pi. Or x is equal to negative 19 pi over 12. Now in this one, to do the same thing, set x plus 7 pi over 4 is equal to 11 pi over 6. Multiply everything by 12, so I get 12x plus 21 pi is equal to 22 pi. Okay. Take the 21 pi over, so I get 22 pi minus 21 pi. I get 12x is equal to pi. Divide both sides by 12, and I get x is equal to pi over 12. This one, x plus 7 pi over 4 is equal to, if I use mixed numbers, 2 times 6 is 12, plus 1 is 13. That's 13 pi over 6. Multiply by 12, I get 12x plus 21 pi is equal to 26 pi. Take the 21 pi over, I get 26 pi minus 21 pi. 12x is equal to 5 pi, or x is equal to 5 pi over 12. Okay, now this one here. So I got x plus 7 pi over 4 is equal to 2 times 6 is 12, plus 11 is 23 pi over 6. Multiply everything by 12. I get 12x plus 21 pi is equal to 46 pi. So then take the 21 pi over, 46 pi minus 21 pi. You get 12x is equal to 25 pi. Divide both sides by 12, and I get 25 pi over 12. Okay. First off, let's just check one of our answers, see if it even seems valid. Well, if I were to check it, put this pi over 12 back up here, multiply this by 3 and that by 3, I get 21 pi, which is 22 pi over 12, which is 11 pi over 6. And if I look at cosine 11 pi over 6, I already said that's equal to square root of 3 over 2, so it works. Now the two that are between 0 and 2 pi are these two right here. So that's the second part of our answer. Now, from here, pi over 6, we added 2 pi. If you look at going from this angle to this angle, negative 19 pi over 12 to 5 pi over 12, I'd be adding 24 pi over 12, or 2 pi. Now going from this angle here over to this angle, I'm also adding 24 pi over 12, or 2 pi. Now I don't see a connection here when I go from pi over 12 to 4 pi over 12. When I say a connection, I mean a consistent pattern I can apply anywhere. So to account for all of our answers, we're going to start with our one that's between 0 and 2 pi, the pi over 12, and I'm going to add 2 pi in, where n is an integer. And there's different ways you can write this. And then our next one will be 5 pi over 12 plus 2 pi over n. And again, n is an integer. And those would account for all of our answers. Because if we kept adding 2 pi and 4 pi and 6 pi and so on for eternity, then we would find that the same pattern holds true. Okay, that was number 12. Let me erase that and let's look at number 19. Okay, number 19. Sine is equal to cosine. Okay. Now there's different ways you could work this one. If we're looking between solve the equation, give them the exact solutions, lie in 0 to 2 pi. Well, if you remember that sine is your y part and cosine is your x part on your unit circle, you simply look on your unit circle and see where sine is equal to cosine, where x is equal to y or y is equal to x. Well, let me erase those. Where they're the same, here's where they're the same, and here's where they're the same. So our two answers would be pi over 4 and 5 pi over 4. That's probably the easiest way. The other thing you could do is you could square both sides, and you could use the Pythagorean theorem, sine squared plus cosine squared is equal to 1 to then solve it down. But this is the easiest way for this particular one. Okay, 11.4, number 9. Where's 11.4 at? Page 940. Okay, and we're looking at number 9. Number 9 says we got negative 20 and 3 pi. Plot the point given in polar coordinates and give 3 different expressions for the point. Okay, 3 pi. I'll start off here, and 3 pi. There's pi, there's 2 pi, and there's 3 pi. So that's where our angle would end up at. Now when you're talking about a negative 20, positive 20 means my point would be right here. Negative 20 means my point would be over here. So that would be my point for that. So again, the 3 pi, we went around to where 3 pi was, and then the negative 20 caused us to go in the reverse direction, a distance of 20 units. So that the assumption would be that this is 20 since I went that distance. But that would be our graph of that. And then it says, come up where r is less than 0, and between 0 and 2 pi. Okay, between 0 and 2 pi. Well, that one's easy. R is less than 0, it's already negative. I know with angles I can add or subtract 2 pi. So if I just subtract 2 pi, then negative 20 and pi would also give me the that same point. Okay, next one is r is greater than 0. And our angle is negative. Okay, angle is negative. Is it less than or equal to 0? Yeah, less than or equal to 0. Okay, I want to end up right here. No matter what, this is where we want to end up, where the point is. We want r still to be negative, which means I want to end up over here, but I want to go negative angle. Well, if I go negative pi, that'll give it to me, won't it? So if I have negative 20 and negative pi would go to right here, and then back 20 would go back to here. So that'd work. And then our last one. R is greater than 0. And theta is greater than or equal to 2 pi. Okay, theta is greater than or equal to 2 pi. Well, if I started here, go, that's pi, this is 2, greater than or equal to? Yeah, greater than or equal to 2 pi. Well, if I just go 2 pi and I'm right here, then 20 and 2 pi would work. Because 2 pi would be right to here, and a positive 20 means it'd be right at this point. There's an infinite number of possibilities on those, in case you're wondering. Because I could go around another 2 pi and have 20 comma 4 pi, and that'd work. I shouldn't say there's infinite possibility in all of them, but some of these there are. Okay, 23. 23 says we got 9, 7 pi over 2. 9, 7 pi. Convert the point from polar into rectangular. Okay. Now this is going to be r, and this will be theta. And x is going to equal to r cosine theta, and y is going to equal to r sine theta. So r is 9, and then we got cosine of 7 pi over 2, and here we got 9 of sine 7 pi over 2. Now 7 pi over 2 isn't in my unit circle, so I want to subtract 2 pi. So I got 7 pi over 2 minus 2 pi, and I'll do the same thing here. I'll subtract 2 pi. Now 2 pi would be 4 pi over 2, so this would give us 9 of cosine of 3 pi over 2, and this would be 9 of sine of 3 pi over 2. Well, if I look at my unit circle, and we got 3 pi over 2, which is right here. Then remember, sine is equal to, or cosine is equal to our x part, which is 0. So this says 9 times 0, which gives us 0. And sine is equal to the y part, which is negative 1. So that's going to give us negative 9. That would give us the point 0, negative 9. Another way to think about that is this is 9, and if I put that in mixed number form, that's 3 1/2 pi. And then if I subtract 2 pi, that gives me 1 1/2 pi, or 3/2 pi. So that's another way you can easily get down here. If this throws you here, you can use mixed number form. Okay, number 39. Let me clear off the page here. Got 7, negative 7. And convert the point from rectangular into polar with r greater than or equal to 0 and 0 between, or theta between 0 and 2 pi. Okay, let's graph this first to see what in the world we're talking about. 7 is right here, negative 7. be right here. So 7, negative 7 be right there. Okay, keep that in mind. Now this is our x, and this is our y. So we can find r. R squared is equal to x squared plus y squared. So r squared is equal to 7 squared plus negative 7 squared. R squared is equal to 49 plus 49. R squared is equal to 98. Drop R squared, and we don't need to worry about putting a plus or minus because R always has to be positive for purposes of what we're doing here. Because we said R is going to be positive. Remember our instructions said R is greater than or equal to 0. Okay, this is 2 times 49. 49 is 7 times 7. So we got R is equal to 7 square root of 2. It doesn't always work out nice like this, but sometimes we can use the fact that cosine is equal to x over r and sine is equal to y over r to find the exact values. So even though we can look at it and kind of see it. So x was 7, so we're going to have 7 over 7 square root of 2, and y is negative 7, so I have negative 7 over 7 square root of 2. That gives us 1 over square root of 2, multiply top and bottom by the square root of 2, and we get square root of 2 over 2. Here these 7's cancel, and I got negative 1 over square root of 2, multiply top and bottom by square root of 2, and you get negative square root of 2 over 2. Now I'm looking at my unit circle for the point. Remember, your cosine is the first part of your point, and the sine is your second part of your point. I'm looking for this point in my unit circle. Well, square root of 2 over 2 and negative square root of 2 over 2 is right here. So it's to be 7 pi over 4. So theta is equal to 7 pi over 4. Now if these did not equal something on a unit circle, you'd have to use tangent theta is equal to y over x. And then you'd have to solve it there, make sure you keep in mind where your inverse tangent is valid, from negative pi over 2 to pi over 2, and find your angle. But this gives us our exact answer. You won't necessarily get an exact answer with this formula. Okay, now we now have r and we now have theta, so I'm going to have 7 square root of 2 and 7 pi over 4. And that's our answer. Okay, number 59. Let me grab a drink here. Okay, 59, we got y is equal to 7. Now we got, remember that x is equal to r cosine theta. Now we got y is equal to r sine theta. And they're saying convert the equation from rectangular coordinates to polar coordinates. Solve for r in all cases. So here, we said r is or y is equal to r sine theta, so we can replace the y with r sine theta. Now they want us to solve for r here, so we'll divide both sides by sine theta, and we get r is equal to 7 over sine theta. Number 78. We got r is equal to negative 3. Now, r is equal to negative 3. If we think what that graph looks like, negative 3, here's my middle. Negative 3 doesn't say anything about the angle, does it? Which means negative 3 from this angle over here would be right here. From down here, negative 3 would be up here. So it's actually a circle. And whether you have a negative 3 or a positive 3 gives you the same graph. Now we said that r squared is equal to x squared plus y squared. Now if I were to square both sides, we'd get r squared is equal to 3 squared or r squared is equal to 9. Notice we'd get the same thing if we squared the negative 3. And then we plug x squared plus y squared in for r squared, and we get x squared plus y squared equals 9, which we know is a circle of radius 3. Okay, 11.7. Let me clear out the page. And we're going to look at number 10. Okay, this is on page 1014. And number 10. Okay, z is equal to 2 square root of 2 minus 2i square root of 2. I'll put the I at the end. Now there's different notation for this. I'm just going to refer to this as x and refer to this as y. Some books will use a's and b's, and I have no clue what this book does. Says find a polar representation for the complex number z. I won't find all these other pieces. I think those are pretty evident once you find the complex number. Okay. Well, remember we have r squared is equal to x squared plus y squared. So x is 2 square root of 2. Y is negative 2 square root of 2. We square the 2, that gives us 4. Square the square root of 2 gives you 2, so we got 4 times 2. And over here we got 4 times 2, which gives us 16 plus 16, or 32. Drop our squared, put or we'll have a positive square root of 32, which is 2 times 4 times 4, which gives us r is equal to 4 square root of 2. Two things we have to find. We have to find theta and we have to find r. Now, assuming this is on unicircle, and it looks like a good sign that it will be, but we'll see. Then cosine of theta is going to equal to x over r. And let me just double check on. Can't do basic math. It was looking like it wasn't going to be on a unicircle. 4 times 2 is not 16. Let's try that again. I'm not the best at basic math. Okay, that's 8 plus 8, which gives us 16, and that's square root of 16, and 16 is 4 times 4, which gives us 4. That's better. Okay, so then we'll have x is 2 square root of 2, r is 4, and that gives us square root of 2 over 2. Sine is going to equal to y over r, so we're going to have negative 2 square root of 2 over 4, or negative square root of 2 over 2. So I'm looking at my unicircle for the point square root of 2 over 2 and negative square root of 2 over 2. I don't know what they're wanting here. Anyway, already got it circled. Square root of 2 over 2 and negative square root of 2 over 2 is 7 pi over 4. It's also 315. So 7 pi over 4, or 315. Now our answer is going to be the form r times cosine theta plus I sine theta. They use a little bit of different notation for that. So we got 4 cosine. Now I personally like degrees best on this. And the reason why is because when you use the other formulas we'll look at here shortly, degrees actually works better. But I noticed that they seem to have a lot of radians there. So either one, I sine of 315 degrees. Okay, the notation they use is they're using 4 and then CIS 315 degrees. But anyway, that's our answer there. Okay, that was number, what was that? Number 10. So let's look at 26. Let me clear this off. Number 26 says we got z is equal to square root of 6 CIS 3 pi over 4. Now this in this form, I won't rewrite it, I guess. I'll adapt. This is r and this is theta. And they're asking us find the rectangular form of the given complex number. Use whatever identity is necessary to find the exact values. X is equal to r cosine theta, and y is equal to r sine theta. So r is square root of 6 cosine of 3 pi over 4, and this will be y is equal to square root of 6 sine 3 pi over 4. Okay, now if I go look at my unit circle, 3 pi over 4. 3 pi over 4 is right here. Cosine is your x part, which is negative square root of 2 over 2. And this will be square root of 6. Sine of 3 pi over 4. Sine is your y part, which is a positive square root of 2 over 2. That's going to give us negative square root of 12 over 2, which gives us negative 2 square root of 3 over 2, because 12 is 2 times 2 times 3, so a pair of 2's comes out as a single 2. 2's cancel, and I got negative square root of 3. And this one, same thing, square root of 12 over 2, which gives us 2 square root of 3 over 2, which gives us square root of 3. And this would be the negative square root of 3 and square root of 3. Now this was our x and our y, but how we write it when we're talking about the complex numbers is we write z is equal to x plus yi. So our answer is going to be z is equal to negative square root of 3 plus square root of 3i. Okay, let's look at 43. Let me clear that off. '43. 43, we got z. Oh, this is not a very nice one. Z is equal to negative 3 square root of 3 over 2 plus 3 halves I. Then W is equal to square root of 3 over 2 minus square root of 3 over 2i. And we want to find, which one was it? 43. W divided by Z. Okay, well first, we have to put these into polar form. So they're in rectangular right now. So this one will be X, and this one will be Y. R is going to equal the square root. This is R squared is equal to X squared plus Y squared. I'm just skipping a step ahead. R is equal to square root of X squared plus Y squared. So we'll have negative 3 square root of 3 over 2 squared plus 3 halves squared, which gives us 27 over 4 plus 9 over 4, which gives us 36 over 4, which gives us 9, which gives us 3. Now since I butchered the other one, let me double check myself here. Okay, 9 times 3 is 27 over 4. 9 over 4, yeah, 36 over 4, 9, 3. Okay. Now our angle, cosine of theta, is going to equal to x over r. X is this, so that's negative 3 square root of 3 over 2 all over r, which is 3, which becomes negative 3 square root of 3 over 6, which gives us negative square root of 3 over 2. Now that's looking promising. Y. So sine theta is equal to y over r. Y was 3/2, so we're going to have 3/2 over r, which was 3. That would give us 3 over 6, which would give us 1/2. So I'm looking at my unit circle for negative square root of 3 over 2 and 1/2. Negative square root of 3 over 2 and 1/2. It's like right there. And I want to choose 150 degrees. So theta is 150 degrees. Putting it in their notation, whatever we're finding here, what was this? This is z. Z is going to equal to 3 CIS 150 degrees. Okay, now we do the same thing for W. So we've got R is equal to the square root of x squared plus y squared. We've got R is equal to square root of square root of 3 over 2 squared plus negative square root of 3 over 2 squared, which gives us square root of 3/4 plus 3/4. Wait a minute, let me double check myself. So I know this comes out in unit circle. Yeah, 3/4. 3/4. Which gives us 6/4, which gives us 3/2. And split that up, and that would give us a square root of 3 over square root of 2. Multiply top and bottom by the square root of 2, and you get square root of 3 times square root of 2 over square root of 2 times square root of 2, which is square root of 6 over 2. This doesn't seem right. We'll see. Okay. And cosine theta is equal to x over r. So we've got square root of 3 over 2 over square root of 6 over 2. 2's cancel, and we've got square root of 3 over square root of 6, which gives us square root of 3/6, which gives us square root of, okay, now it's looking better, square root of 1/2. Split that back apart into square root of 1 over square root of 2, and multiply top and bottom by square root of 2, and you get square root of 2 over 2. Now sine. It's going to be y over r, and y is very similar, except for it's negative square root of 3 over 2. Over r, which is still square root of 6 over 2. And since it's the exact same values as that, I know that's going to give us a negative square root of 2 over 2. So we're looking for something on our unit circle that's square root of 2 over 2 and negative square root of 2 over 2. Okay. Let's go look for that. Square root of 2 over 2 and negative square root of 2 over 2 is right here. So it looks like our angle is going to be 315 degrees. So was this W? What was R? R is equal to the square root of 6 over 2. CIS, 315 degrees. Okay, now what they're wanting, and now we're finally got through that, is number 43, we want W divided by Z. What you do is you divide your R's, so I'll take the square root of 6 over 2 and divide it by 3, and then you subtract the angles. So we'll take 315 degrees minus 150 degrees. Now this is going to give us the square root of 6 over 6. This denominator just drops down with this one. You multiply them together. So 2 times 3 is 6. And was that 165 degrees? And I think they said leave it. Express your answers in polar form. Okay. So that's our polar form. Now, you would want your r still to be positive, and you'd want, if possible, and then you want this angle between 0 and 360. But that would be our answer. Okay, so let's take a look at the next one. That was 43, so 54. That wasn't looking good with how that radius was looking, but it actually came out pretty nice. Though I suppose it depends upon your definition of nice. Okay, 54. What do we got here? Negative square root of 3 minus I to the third. And, okay. Express your answers in rectangular form. Okay, well, first off, we had to put it back, put it into polar. So this is going to be our x, and then whatever numbers here are going to be our y. So x is negative square root of 3, y is negative 1. So we got r is equal to the square root of x squared plus y squared. X is negative square root of 3, so we got negative square root of 3 squared plus y, which is negative 1 squared. So that's going to give us 3 plus 1, which is 4. And square root of 4 is 2. Okay. Cosine is going to equal to x over r, and sine is going to equal to y over r. X was negative square root of 3 over r, which is 2. And sine is y, which is negative 1 over r. So we're looking around our unit circle for negative square root of 3 over 2 and negative 1/2. And that'll give us our theta. We want it into degree form. Okay. Negative square root of 3 over 2 and negative 1/2. That would tell us that theta is equal to 210 degrees. Okay, so this right here now becomes r, which is 2, and then I'll use their CIS notation, 210 degrees, and then the third power here. Now, I'm going to look this formula up just to refresh my memory. If I remember right, you take the r to the third power, and then you multiply your angle times the 3. But let me go ahead and check that. I don't teach trig every day, so I don't have those formulas necessarily memorized. Let me see. Okay. Yeah, take the absolute value and then raise it to the power. Yeah, I was right. Okay. Which means 2 to the third is 8. Then CIS, multiply 3 times that gives us 630 degrees. Typically, we want that in our unit circle from 0 to 360. So I'll take 630 degrees minus 360. And since that seemed to be doing poor at basic math, let me come over and do that. 630 minus 360, 270 degrees. But they said to put it back in the rectangular form. Okay, so this is our r, and this is our theta. X is equal to r cosine theta, and y is equal to r sine theta. So we're going to have 8 cosine of 270 degrees, and y will be r sine of 270 degrees. Okay, if we look up 270 degrees on our unit circle, 270 degrees is right here. Cosine, which is our x part, is 0. So this will be 8 times 0, or 0. And Sine of 270 degrees is our y part, which is -1. So we got 8 times -1, which is -8. And our answer is going to be of the form x plus yi. Well, x is 0, y is -8. So our answer will be z is equal to -8i. Okay, let's look at number 66. Um, 66. The two square roots of we want the square roots of z is equal to -25i. Now, we want to put this into polar form. And then it says, express your answers in polar and convert them into rectangular. Well, polar kind of goes right along with it, but this is 0 minus 25i. So this is going to be our x, and this is going to be our y. So r is going to equal to the square root of x squared plus y squared. So r is equal to 0 squared plus -25 squared, which gives us r is equal to 25. Cosine is equal to x over r, and sine is equal to y over r. X is 0, so we're going to have 0 over 25, which is 0. Sine is sine is equal to y, which is -25 over 25, which is -1. So I'm looking for a point on my unit circle that's 0, -1. Well, that one's pretty straightforward. 0, -1 is, oops, 0, -1 is right down here. Okay, which is 270 degrees. Oops. I'll eventually get back there. So theta is equal to 270 degrees. So our polar form is 25 CIS 270 degrees. So this is what we're working with. And again, I don't got this formula memorized, so let me go look at it. Here it is. Now, the nth root. So n is how many roots you have. And we said we have the square root, so n is 2. Okay, and then it says that you want to go from w sub 0 up through w sub n minus 1. N was 2, so that's 2 minus 1, so we're going to have w sub 0 and w sub 1. Okay, so from the first one here, we're going to have the square root, or the nth root, sorry, of r. So we're going to have n is 2, so the nth root of r, and r we said was 25. CIS, and then we got theta over n. Okay. Theta we said was 270 degrees over n, which was 2, plus 2 pi over n. So plus 2 pi, and n was 2, times k. And k is whatever number's on this subscript here. So times 0. So that's 5 CIS. 2's canceled there, and pi times 0 is 0, so that drops away. So that gives us 135 degrees. And that's our first answer in polar form. Now we do the same thing on this one. So we got the nth root of r CIS 270 degrees divided by n. So that's still 2 plus 2 pi over 2 times k, which in this one is 1. So times 1. So that gives us 5 CIS. Now this is, I put this into degrees, which I should, I'm having a mixture of degrees and radians here. This is still 135 degrees plus 2's cancel, and I got pi, but that's in radians. So in order to figure out that one is, I have to change that pi to 180 degrees. And that's going to give us 10, 11, 315 if I added correctly. Yeah, 315. Now we could get exact answers for those. Those are what they are in polar form. And for a rectangular form, if I, well actually, let me mention it. To get the exact answers, you could take the 135 degrees and look that up on your unicircle. And for 135 degrees over here, you could get those values. But when they say to convert it to rectangular, let's see what happens. This is our r, and this is our theta. So x is going to equal to r cosine theta. And I forget what I said. This is the exact form. Need a break, I guess, after an hour and 15 minutes. Okay, so I got 5 and then cosine of 135 degrees. And here I got 5 of sine 135 degrees. Okay, 135 degrees, cosine is our x, so negative square root of 2 over 2. So I got 5 times negative square root of 2 over 2. This one would be 5 times a positive square root of 2 over 2. So this would give us, in rectangular, we'd have negative 5 square root of 2 over 2 plus 5 square root of 2 over 2, 5 square root of 2 over 2 with an I to the side. Okay, now this answer over here. We're going to have x is equal to r cosine theta, and y is equal to r sine theta. So we'll have 5 cosine of 315 degrees, and we'll have 5 sine of 315 degrees. Now cosine of 315 degrees, here's 315 degrees. Cosine is square root of 2 over 2. And sine will be a negative square root of 2 over 2. Which means the other answer will be z is equal to 5, I don't know why I put parentheses there, 5 square root of 2 over 2 minus 5 square root of 2 over 2 I. And those are answers in rectangular. And that's the last problem.